So what does happen if when the angles in radians get smaller? What happens to sine, cos, and tan? Well, basically, if we're looking at sine x, it becomes the same as the radian value. Sine of x is equal to x. Tan of x is equal to x, and cos of x will become basically 1 because as it gets smaller, approaches 0. We know cos of 0 is 1, so it'll get closer to 1. Also, we'll get this result, and it's the same for tan. If you've got sine of x on x and you're taking the limit, as x gets smaller, basically it'll approach 1. And I've used a spreadsheet to do this. And even if we have a look here, at zero point 0.5 a radian, which is not too small, sine of 0.5 radians is 0.47. So it's not too far away. Sine of when we've got 0.4 radians, we get 0.389 for sine x. 0.3 radians, sine of 0.3 radians is 0.295. Sine of 0.2 radians is 198. And then 0.1 gives us 0.09. 0.09 gives us sine of that is 0.08. So you can see how they're getting really close. Very, very close. So 0.2 is your 0.199. And even 0.1 of a 0.01 of a radians gives you sine of 0.1 of a radian is sine is 0.01. So it's very, very close. And you can look at sine of x on x. How close are these ones getting to 1? Like, until it's like we got the 4 decimal places 0.9999. So you can see how what happens when we actually do the calculations. The values get really close. If you want to set up a spreadsheet and have a look at this, remember your spreadsheet's actually set to radians, so that's what happens. So what we can do is an application that we might see, not necessarily in the 2-unit course. We don't see it very often in the 2-unit course. More than likely, it's all appear in an extension 1 paper as a harder 2-unit. But if we've got the limit as x approaches 0 of sine of 2x on x. Now, the thing with this one, what we want to do, we don't want sine of 2, we want sine of 2x over 2x. So we can change it around. We can do a bit of manipulation like we've done before and put a 2 in there and put a 2 in there. So we've divided by 2 and multiplied it by 2. That would actually equal 2 lots of. And the limit of x approaches 0 of sine 2x on 2x. It's the same angle. So that would equal 1. So it'll equal 2. So there's an application of it. As I said, we don't usually see that, but all it is just manipulating the angle to get what we want there. So in another application here, if we look at the angle we've got here is 0.31 degrees, which is really small. So 0.31 degrees, what we want to do is look at the diameter of the moon. It's saying 400,000 kilometers away from it subtends an angle of 0.31 degrees. So if we do our calculations here, we can get a triangle 15.5 not degrees, but it's minutes. So we want to find the value of x, so we can find the diameter of the moon. So if we substitute that in and look at sine of 0.0045, which is 15.5 minutes, really we just, instead of doing the calculation, it's going to be 0.0045. We're just going to take that exact value, multiply it by the 40, gives us x being 1803.5, which means our diameter would be twice that. So it's approximately 3,607 kilometers. So we've used that application. They're not having to worry about taking sine of that angle. We're just going to take the angle in radians because it's going to be it should be very, very close, if not exactly the same.